In this video, we're going to be looking at topic 8GC, which is metals and water, and this is part of the uses of metals topic for year 8. So our learning objective today is to look at how metals react with water, and by the end you should be able to describe the reactions of metals with water, be able to place metals in order of reactivity series, and continue being able to write word and symbol equations for different chemical reactions. So this is section 3 of topic 8G, and we looked at metal properties and corrosion. So now we're going to look at how we react metals with water and then make a reactivity series. So just to recap, corrosion is any reaction of oxygen on the surface of a metal, and the metal reacts with the oxygen to form this metal oxide on the surface. Remember, when we're talking about corrosion of iron, we call this rusting, but rusting is only for iron, and we need water and oxygen for this to happen. We can protect our metals by painting them or greasing them in order to stop any oxygen or water from reaching it, and we can use symbol equations, which uses a chemical formula instead of the word equations that we've been using. And remember, you will use these again when you get through to GCSE, and the more you practice them, the better you will get. But don't worry if you're not too good at them just now, because you are still just learning. So some metals are extremely reactive, and they are so reactive that we cannot use them for things like building materials, because if they did, then they would completely dissolve or be destroyed. So if you've got any substance that is going to be exposed to weather, for example rain or wind or lots of oxygen, you don't want to make it out of a metal that's going to react very quickly. And the metals that are on the far left of the periodic table, like the alkali metals, are all going to react very quickly with cold water. So we're looking at lithium, sodium, and potassium. They're all in group 1, or alkali metals. And we can also look at our group 2 metals of calcium, because calcium does also react with water, but really we want to look at our group 1 elements. They're the ones that are going to react very quickly. So that means if it was to rain, these metals would be completely destroyed and your building structure would collapse, which of course we don't want to happen. When metals react with water, they're going to form hydrogen gas, and they're going to form a metal hydroxide. For example, if we have sodium plus water, we make sodium hydroxide and hydrogen. And this is an alkali. Now, you studied alkalis back in year 7. So remember, this is going to have a pH above 7, and it will turn your universal indicator a blue or a purple colour. So these are going to be our alkalis. And then we make hydrogen gas as well. And if we make hydrogen gas, we can identify this because it is going to burn with a squeaky pop. And you should have learned that already in previous topics in year 7 and also in year 8. Now, potassium reacts very much the same when it reacts with water, and this time we make potassium hydroxide, but I still make hydrogen. This video here is a good link to show you the alkalis reacting, so alkali metals reacting in water, and I will post this in the description if you want to check that out. So what we now want to do is we want to practice converting this word equation into a symbol equation. And to make you aware, we've got hydroxide is going to be OH. Okay, you're not expected to know that at this point. You'll learn more about that at GCSE. But for now, I'm going to tell you that it's OH. And sodium and the hydroxide are in a 1-to-1 ratio. So we've talked about this before. If they're in a 1-to-1 ratio, it means for every 1 sodium, I have 1 hydroxide. So let's try and write out a symbol equation. Well, sodium, using our periodic table, has the symbol Na. We do a plus sign. And then water, you should know, is H2O. We have our arrow. And then the sodium hydroxide is going to be Na and the OH next to each other. And because I have sodium, oxygen, and hydrogen. And then I'm left with hydrogen gas, which is H2. So hydrogen gas is always H2. If I then try potassium, I've got K for potassium, checking my periodic table, plus H2O for water. My arrow, again, the K and the OH are in a 1-to-1 ratio. So I have KOH plus the H2 for hydrogen. Now you might want to practice writing these out. Now some of them might be a little bit tough for year 8, but you can always practice and you can ask your teacher for some extra examples if you want. So this is just some pictures to show what happens. So if I have sodium reacting with the water, you can see that I have my indicator here, and the indicator has turned purple. And this tells me that I have my alkali, which we've already said. And I'm going to make my hydrogen gas as my other reactant. If I do it with calcium, you can see that this time I have the bubbles telling me that I have a gas, and we've collected the gas, and the fact that it burns with a squeaky pop proves that it is hydrogen. So it's important to know that the alkali will turn the indicator purple, and the hydrogen will burn with a squeaky pop. These could be questions possibly in an exam, so it's important to know these two things. Now, some metals do not react with cold water, like gold, or they react very, very slowly, like magnesium. Now, magnesium can still react, and we make magnesium hydroxide and hydrogen. Now, we're not going to try a symbol equation for this because this is a little bit more challenging, but we still make our hydroxide and our hydrogen, whereas gold, when we add it to water, has no reaction. And we know this. If we have a gold watch or a gold ring or a gold necklace and it gets wet, we know that it doesn't dissolve away, or else any jewellery that we would wear outside in any rain would completely dissolve. And we know that's not the case. And again, this is another link to show the different reactions of metals and water, and you can find this in the description. Now, because we have these metals reacting with oxygen and water in very much the same way every time, we can write out something called a general equation. And what this means is that when I react any metal with oxygen and it reacts, I'm going to make a metal oxide. If I react any metal with water and the reaction goes ahead, I'm going to make a metal hydroxide and hydrogen. Now, be aware that not all metals will react. Okay, we've just said that gold is not going to react. What we're saying with these general equations is if they do, this is how they react. And we can see the differences in these reactions for different metals. Some of our metals are going to react very fast, while some of them are going to react very slow. Some of them might be explosive, whereas some of them you might see 1 or 2 bubbles. Not very much happening. And this property is something that we can take advantage of, and we can look at these differences in reactivity and start to put the metals into something called a reactivity series. And a reactivity series is a list of metals ordered by their reactivities. Meaning we have most reactive at the top and least reactive at the bottom. And this is an example of the reactivity series. So we're starting with our really reactive metals from the alkali metals, so potassium, sodium, and lithium, going all the way down to silver, gold, and platinum. And you can see the key down here at the bottom. So if it's got the little fire, it means it will catch fire when it reacts. At 3 ticks, it reacts very quickly. 2 ticks, it reacts quickly. 1 tick, it will react, but not too fast. The 3 dots is a partial reaction or a very slow reaction, or a cross for no reaction. So we can see that potassium reacts violently and explosively with both oxygen and water, whereas platinum doesn't react with oxygen or water at all. So we have our high reactivity at the top and our low reactivity at the bottom. Now, for year 8, you're not expected to memorise this, but it is very good for you to learn it because it can be very useful, and you can use a rhyme to help you remember the reactivity series. And the best way to do it is to use the first letter of each element to help build this rhyme. So here are 2 examples. We've got Police Sergeant Little Charlie Mazittle, as if that's the surname, caught me stealing gold plates. So we can see P, potassium, S, sodium, L, lithium, and so on and so on. Or, please send lions, cats, monkeys, and zebras into laboratory classmates, signed General Penguin. It doesn't really make too much sense, but that's okay, as long as it's something that you're going to remember. So if you read that and you think that's funny and you're going to remember it, then that's the whole point in it. It's not about what the rhyme actually says, it does it make it memorable. So you might want to try and think up your own rhyme to see whether you can come up with something. So we're going to look at an example question, and this is a question that could come up in a test. So you have your reactivity series and you're told that metal A has no reaction with cold water. So I'm going to underline no for cold water, and it reacts slowly with oxygen. Metal B reacts explosively with cold water and oxygen, and metal C reacts slowly with cold water and it burns in oxygen. Now we want to put these metals in order of reactivity, and we want to justify why that is. So the first thing that you want to do is you want to figure out where the metals are going to sit in the reactivity series. So we will use the key to help us here. So for metal A, it has no reaction with cold water. So we want to go up to where we have all the crosses, so we can see between lead and copper. And it's probably going to be in there, and it's going to react slowly with oxygen, which means then it must be below copper. So A is probably going to sit in between copper and mercury because it doesn't react with water and it reacts slowly with oxygen. Now it could be between mercury and silver or between silver and gold because it's the same justification, but we're just going to say it's between copper and mercury. Metal B reacts explosively with cold water and with oxygen. Now that's probably going to be near the top because we know that we have that explosive, and the only metal that does the same is potassium. So it either has to be above potassium or slightly below. So we're just going to put it above potassium here. So this is metal B. And then metal C reacts slowly with cold water. So then we're looking at around magnesium and aluminium because we've got our 3 dots, and it burns in oxygen. So I want to go for the burning, go down to the bottom for magnesium, then it must be below that because whilst it burns, it reacts slowly in cold water. So C is going to be in here. So my order of reactivity is going to be B, then C, and then A. And I've justified my answers by matching up the different things that I've been told to put them in position. Now you could write that out as a sentence because you wouldn't be able to obviously explain it as a video, but they would give you very specific information they would want you to say. But we want to say that B is the most reactive because it reacts explosively. Then C, because it still reacts with the water and it burns in oxygen. And then A, because it has no reaction with cold water and it reacts slowly with oxygen. So just by using the reactivity series, we can figure out what these unknown metals are in terms of their reactivity. So our learning objective was to look at how metals react with water. So hopefully now you can be able to describe the reactions of metals with water. You can place metals in order of reactivity, and you can write word and symbol equations for the reactions. And that's one that we'll continue to work on as we go through Key Stage 3 and GCSE. If you have any questions, please feel free to leave a comment below, and we hope to see you back soon for more revision videos.